Bismillahirrahmanirrahim. Welcome to the new lecture of Discrete Mathematics. Today we are going to study about Principle of Mathematical Induction. So what is mathematical induction? So this is a general review or introduction about it. In algebra or in other discipline of mathematics, there are certain result or statement that are formulated in term of n. As you said, like you can be seen a number of statement like 1 plus 2, 1 plus 3, 1 plus 4, and 1 plus 5, blah, then plus up to n. So it's just like an n statement of n, or where we can say n is a positive integer. So to prove such statement, well suited principle that is used based on the specific technique, and that technique is called mathematical induction. What does it mean? That sometimes you have equation on the left and right side. So once you have an equation left and right side, so you need to be specify or prove that left hand side or right hand side is or equal. So for that we are using such kind of equation and such kind of method or technique which is called mathematical induction. So for the principle of mathematication, we have a three condition. We can say three conditions. So the first you need to be know about that the principle of mathematical induction is the one such tool which can be used to prove a wide variety of mathematical statement. So later on you will see the statement how we can write the statement. So each such statement is assumed as a p of a n. So the p of n mean whatever you have as a statement, the statement will include n associated with the positive integer n. So n will be the positive integer. So we have basically three kind of a condition. The first one like that whenever you are putting n is equal to 1, so p of 1 will be equal of left and right side will be equal for n is equal to 1. This is the first one. Then you can say that assume it consider that p of k will be equal, so it will be assumed, and then for p of k plus 1 we will need to be proved that for when we are putting n is equal to k plus 1, so the statement will need to be satisfied. So we will prove that. So I will give you just a simple example how we can apply these three conditions. So for example, use mathematical induction to prove that 1 plus 3 plus 5 plus so on in n 2n minus 1 is equal to n square. He is saying that this right hand side is equal with the left hand side. We need to be proved out. The first condition is now. So for all integer, for all which is n is greater or equal to 1. So our question is p of n be the equation which is equal to this. So first we need to be put n is equal to 1. Then this is the first one. The second is that we will say that for p of k mean that n will be equal to k. Assume that it's true. Then for a third one we will prove it out that for n is equal to k plus 1 we need to be proved that. So just keep in mind these three conditions. Okay. So now the first one is basic step, p of 1 is true. So you will be put n is equal to 1 to the left and right side. So it will be equal to 1 and 1. How it will be 1 and 1? You can see it. When you put the 1, so 2 1 minus 1 1 and 1 is just so 1 equal to 1. So the first condition is satisfied. Okay. So now this is the first statement which is satisfied. The second is suppose or assume that p of k is true for some integer which is k is equal or greater than 1, which are we need to be suppose that. So that's why where we have to be n, just put out the k. We assume that this is equal. So now the third step is we need to be proved now that when we are putting n is equal to k plus 1, so the left and right side need to be equal. So for that statement keep in mind which term you are going to be add or subtract to the right or left hand. Okay. I'm telling you now. So what we are going to do, that where you can see k or n, so put out n is equal to k plus 1. So this is your basic equation. So 2 with the same place, then k is equal to k plus 1 and minus 1 and k plus 1 whole. We are going to be prove this statement now. We are going to be prove that now. This is our goal. We need to be receive, or we need to be reach to this goal now. So how we can prove that now? So see now. So you have a right hand side and left hand side. Okay, so just you already put that 2 k plus 1 minus 1. This is your left hand side. So just simplify it out. When you are simplified it, so it will be 2 k and plus 1. So when you simplified the equation, of the left hand side, and whatever you got here, like 2k plus 2 minus 1, so 2k, and it will be minus, so it will be 2k plus 1. So whatever you got it here, just add this term with the right side. Okay, just add this term with the right side. So how? This is your left hand side. Simply you just got the value 2k plus 1. It will be add on the right side, it will be add on the left side. How? When you are adding this term to the right side and this term with the left side, so when right is come toward the left, then it will be plus, it will be minus. So again the result will be 0. There is no there will be no change in the equation, so it doesn't matter. So if this equation is going to the left side, so again it will be plus minus, it will be again 0. So there will be no change. Okay, so this is your left hand side. So now in our right hand side, what we are going to do, so you first of all you can see we have a right hand side. In the right hand side we just have a k square. Okay, just k square. So k will be on the same place, and add this value and add this value. So just add it here. Okay, so now this is your right hand side now. So k square plus 2k plus 1. Okay, just it's a formula, a square plus b square plus 2ab. So k square, it's your a, plus b square, b is your 1, then 2, a is 1, b is k, or a is k, b is 1. So a plus b whole, it's your proof now. If you can see what we was need to be prove out this thing, so we already proved that. So this is the way how we can prove. Okay, so just keep in mind 3 steps. First step is n is equal to 1. It will be need to be prove out that both sides will be equal. Then the second step is you need to be assume, we need to be suppose, we need to be consider that for n is equal to k it is satisfied. Then for the third step is that when n is equal to k plus 1, so for n is equal to k plus 1 we need to be satisfied the equation. So how we can satisfy the equation? Simple way, just put the values on the left hand side where you have n or a k value, simplify it, whatever you got from this just add it on the left and right side. Let's add left and on the right side, that then just simplified it and you will get your required answer. So these were a 3 step and 1 pk and then pk plus 1. Okay, so come to the next one now. So again the same statement will be here, that the statement is true for n is equal to 1 if the statement is true for n is equal to k, where k is some positive integer. Then the statement is also true for n is equal to k plus 1, and so the truth of p of k implies the truth of p is equal to k plus 1. So and then p of n is true for all natural numbers. So this is just basic 3 steps we need to be apply on each mathematical induction, where we need to be prove left and right hand side. So the type of equation we will see, the equation will be statement giving expression about summation or multiplication of a special series. So you know about, as you saw in the last example 1 plus 3 plus 5, or 1 plus 2 plus 3 plus 4 plus 5, and it's just like a series of odd numbers, series of natural numbers, series of integers, series of even number, and so on. Then statement to show the divisibility of an expression by a certain natural number. What does it mean? It said that you have a series, you have an equation, so the equation will be divisible by some number, divisible by a some. First we are saying that 2 plus 4 plus 6 plus 8 plus 10 plus 12 and so on. It is divisible by 2, divisible by divisible by 2, you can say. So it's just like you can be have a statement like that. And another example is statement containing sign of inequality. You can be see it can be greater than, it can be less than, it can be equal or greater or equal and less than. You can see it later on in examples. So coming to the question or example, whatever you can say it. So for all n greater than or equal to 1, so you can say inequality here. It can be equal and greater, so equality will be here, but it's a condition statement. Prove that 1 square plus 2 square plus 3 square plus 4 square and so on plus n square is equal to n into n plus 1 into 2n plus 1 divided by 6. This is your question. So now we need to prove that mathematical induction. So the first statement is n is equal to 1. Put out n is equal to 1, so left and right side will be equal. Okay, left and right side are equal. Then the second is suppose that for n is equal to k, it is true. So for n is equal to k, it's true. So let's just put out k everywhere. So this is the position. So a third is now we need to prove n is equal to k plus 1. So for n is equal to k plus 1, or p of k plus 1 is 2. So how it can be 1 square plus 2 square plus 3 and so on, plus k square. So when you are putting here is n square, so put the way replace n by k, so k will be k square, and you know your n value is k plus 1, so put here, so it will be k plus 1 whole square. So if you simplified it again, the number will be the same. So just 8k plus 1 whole square on the both sides. So you can see it now. So plus k plus 1 added here, and also k plus 1 whole square will be added on the right side as well. So just simplify it now. So just simplified it, because just your mathematics, just take a LCM because it's divisible by 6. Take LCM at the end, you will got the answer. So k plus 1 plus 1 into 2 k plus 1 plus 1 divided by 6. What does it mean? Now how it can be satisfied, you keep in mind how we can satisfy it. Now where you have a n, so the position of n need to be k plus 1. Okay, so a position of n is will be k plus 1. If you can see here, so here is k plus 1, but in the actual we have a k just now, it's here k plus 1. So for n is equal to k plus 1, it's proof k plus 1. Now see the second one. So then n is k plus 1, again k plus 1 plus 1. So see it here. So k plus 1 plus 1. Then you have a 2n plus 1. So 2 into k plus 1 plus 1. So 2 k plus 1 plus 1 and divided by 6. So it means for n is equal to k plus 1, your required answer is satisfied. Okay. So coming to another example, prove that the following by using the principle of mathematician for all n is belongs to all integer number. So then now you can see it is a series of multiplication 1 dot 2 dot 3, just like multiplication, then 2 dot 3 dot 4 plus and so on. Then there is n into n plus 1, n plus 2, so on, then is equal to. So the first will be again the same, n will be 1, need to be satisfied this first. Then suppose for n is equal to k, it is satisfied, and then for n is equal to k plus 1, we need to be prove that left hand side and right hand side are equal. Then at the end that all k's will be the all integer number. So step 1, put n, so both side will be equal, so 6 and 6, both side are equal. Then for n is equal to k, so the you know that assume or its position, so it will be true. And the third step, you know what we can do, so just put the value of n is equal to k plus 1 everywhere. So put value of n, so k into k plus 1, k plus 2. So what we are going to do, just put the value of k plus 1. Okay, so then k plus 1, k plus 1 plus 1, k plus 1 plus 2. So this is your required now. Okay, this is your, so if you can simplify this equation, then whatever you got, you just add it with the right hand side and left hand side. So we don't need to be simplified there. Just k plus 1, k plus 2 and k plus 3. So k plus 1, k plus 2, k plus 3, add it on the both side, on the left hand side and on the right hand side. So we need to be proof for the right hand side, that so add it on the right hand side. So k plus 1, k plus 2, k plus 3, simple. So now just simplify it. So k plus 1, k plus 2, k plus 3 divided by 4. So you need to take a LCM first. It's your LCM. So 4. So then we have a common, k plus 1, k plus 2 and k plus 3 are common. So k plus 1, k plus 2, k plus 3 are common. What is left? K plus 4. So k plus 4 will be left. So it means your desired answer is the same, is proved. Now how you can see it? So where you have n, we need to have a k plus 1. So n, we need to have a k plus 1. Okay, then you have a where is it? So there. So k plus 1. So then k plus 1 plus 1, again see it, k plus 2. So k plus 1 plus 1, k plus can be right, k plus 1 plus 1. Then you can see n plus 2. So k plus 1 plus 2. So you can see k plus 3. So k plus 1 plus 2, then k plus 1 plus 3, k plus 1 plus 3 divided by 4. So again it's proof. So the result is this p of k plus 1 is true whenever p of k is true. Hence from the principle of mathematical induction, the statement p of m is true for all natural number. So just keep in mind, which is simplest way, simplified this position, put n or k equal to k plus 1, put this thing in this position and simplified it. Whatever you receive from this position, just add that number with the left and right side. So don't touch with the left hand side, just touch with the right hand side and prove it that where you have a n, so we need to be replace n by k plus 1, n with k plus 1, whatever you have. It can be n plus 1 in an actual question, but in n plus 1 we need n, so we need to be, let's see, if you in actual we have n plus 1, in a question we have n plus 1. So in a result here, what we can do, so where we have a n, just n need to be replaced by k plus 1 with the proof. You will prove it out. So the result will be k plus 1 and plus 1. So this is the simple process. So everything is based on this position. Another example where we don't have a left and right hand side, we have just like a proof now that 7 raised to power n minus 3 raised to power n is divisible by 4. It's equation about like divisibility. Now we saw in the slide that we have a divisible statement, we have inequality statement and so on. So we can prove it out first, that p of n is equal to n raised to power n. This is minus, this is not plus, this is minus. So 7 raised to power n minus 3 raised to power n is divisible by 4. So the first statement is n is equal to 1. So when n is equal to 1, so the result will be 4. It is divisible by 4. So the first statement is proved now. The second is n will be k. So just it's a supposition. So n will be k. Okay, it's divisible by is supposition. Yet consider that 12 is divided by 4. Consider that. So consideration is always be imaginary. We just thinking about. So and the third is that where you have a n are replaced with the k, then it will be k plus 1. So the third step is k plus 1. So for a k plus 1 we need to be simplified the equation. Okay, so now this is the way how we can simplify the equation. So this is a bit of difficult, a little bit difficult, because we don't have a left hand side where we can put k plus 1, then from simplify the equation and get the value and add with the left and right hand side. So this is a bit change. So how is it that we had a n value 7 raised to power n. So where we have n, just replace n by k plus 1, because we said that the equation is divisible by 4. So we just proved it now. So it means where we have a k plus n is equal to k plus 1, it is satisfied. So 7 k raised to power 1 7 raised to power k plus 1 minus 3 raised to power k plus 1. Okay, so now just simplify this equation, so it's up to how you are going to be simplified. It is based on factorization, it is based on taking 8 and subtract something else. So we are doing some addition or subtraction. So 7k plus 1 is the same position, 3 power k plus 1 is the same position. What we are going to do, I'm taking a 7 from this one and 3 raised to power k from this one, and then add and subtract. So when you are adding this value and subtract this value, then again it will be cut, then the result will be 0. So it means there is no changes due to this number. Okay, so we can add it. So this number is going to be 8. So again here we can see, so we can write 7k plus 1, it can be write like a 7k plus 1, we can write it like that. So 7k dot 7, because when the bases are same, the power will be added, so the result will be 7k plus 1. Okay, so that's why I took a common of 7, because 7 can be written here. So 7 common between these two terms, so 7 is a common, so 7k minus 3k is left here. Then what is common here? Here is 3k is common, so 3k common is then 7 minus 3. Okay, so now just simplified it. So now simplified this equation. So if you can see 7k minus 3k. Okay, see here we say that 7k minus 3k is equal to 4d. 4d means that it is divisible by 4. So this is called 4d. 4 is your number which is which will divide this equation, and this base of divisibility. Okay, so again, so 7k minus 3k we have, so it will be replaced by 4d. 7 will be the same position, so 7 minus 3 and into 3 power k it will be here. So just simplified it will be 4 and dot 3 raised to power k. So what is common now? 4 is common, 4 will be here. This is your equation. So it means this equation is divisible by 4, because 4 is outside, whatever the number will be inside, whatever the number will 4. Let's see, the number is 1, so 4 multiplied with 1 4, again divided by 2, then the number will be 2, so 4 multiplied by 2 8, so 8 again is divided by 4, then 3, so 3 multiplied by 4 is 12, 4 is again divided by 4. So it means the equation is divisible by 4. So you will need to be proved like that 4 will be the outside, because the term which we need to divisibility, that is 4 is your divider, so the 4 will be in the outside. So this is your proof, basically how you can solve the equation. This is a statement, this is the way how you can find. So we have two type of equation which we already solved. The first one was we have left and right hand side, so put the value in on the left hand side, so simplified it, and then add on the left and right hand side, on the both side. Then we have equation like divisibility. On the divisibility, just where we have a n, so just put the value of n is equal to k plus 1, simplified, and then get the divisibility answer. So now this is another example, prove that the following using the principle of mathematics for all n belongs to the n is equal to n plus 1 is so on. So the first statement, we will put n is equal to 1. So this is another example. So for n is equal to 1 first, then for k is another, then the third is k plus 1. So when k plus 1 is, so this is k into k plus 1, k plus 1 plus 1, k plus 1 plus 5, which is multiple of 3. So multiple of 3 mean, come here now. So where we have a k, put out the value, where we have a k or n, just replace k or n with the k plus 1. So k plus 1, k plus 1 plus 1, we replace k or n with the k plus 1 value. So the simple thing, k plus 1 will be the same, just multiply these two values, multiply with these two values. So k will be multiplied, this k will multiply with the, like we can write this value like that, because it will be simple, k plus 5 plus 1. So first k will multiply with k plus 5, then k will multiply with the 1, then then 1 multiply with k plus 5, then and so on. So and this is k 1 plus 1 will be 2, so 2 will multiply with the k plus 5 and 1. So how k multiply with the k plus 5, then k multiply with the 1, okay, then is 2, so 2 multiply with k plus 5, then 2 multiply with 1. So this is your desired equation. So just simplified it now. When you are simplified this equation, your required answer will be this one and this. So then after that you just take a common, so k plus 1 k plus 5, it will be the same, then plus what is the common between these two, so 3 into k plus 1, okay. So it's just your mathematics how you can take a common from a term. So when you took that, so then k into k plus 1 k plus 5, so if you remember these values, if you see here k into k plus 1 and k plus, it will be 3D. So k into k plus 1 and k plus 5, it will be 3D. 3 will be on the same position, k plus 4 will be on the same, and k plus 1 on the same. So then just simplified again, 3 is common again. So if you can see this, so 3 is multiple of every number now, so it's again the proof. So it's totally based on your mathematics, how you know about the mathematics, taking LCM, taking a common, take a factorization and so on. So everything is based on your mathematics practice. So coming to the another example, prove that 2 raised to power n is greater than n for all positive integers. So this is the inequality equation now. So let p of n be the given statement. So again p of n is 2 raised to power n. First is n is equal to 1, then replace n with the k, then so he's saying that prove out now. So prove out 2 raised to power n is greater than n, so it means k plus 1 is satisfied, okay. So we are just prove the equation now. How is it? Okay, let's see here. So we are saying that p is equal to k plus 1, where we have a n or a k, so put out k plus 1. So 2 raised to power k plus 1 is greater than 2k, okay. So if you see here is n, okay, here is n, and we are saying that it's, if you can apply that 2k plus 1, so it can be right 2k into 2, then it is greater than k plus 1, okay. So we need to find this kind of equation. So for this kind of equation we can add 2 with the both hand side. When we are adding 2 on the both hand side, 2 plus 2 is to our k is greater than 2k, so it can be 2k plus 1. So we find it that it's a 2 power k plus 1. 2 power k plus 1 is greater than 2k, so it's true that 2 power k plus, it's a power, maybe if k is greater than 2, so the value will be greater than 2k, okay. So we can also say that k plus k, we can say that k plus k is greater than k plus 1, because k is a greater value and 1 is fixed one and a small value. So it said that k plus k will be the greater than k plus 1. So this is actually a bit of conceptual question, that how you can going to be defined and how you are going to be simplified the equation, because he said that the equation of 2 power n is greater than n. So applying the equation, multiply with something, but the actual thing is, because it's an inequality equation, so in inequality equation it doesn't matter that it's going to be make equal or not. You just put that left hand side or right hand side is greater than left hand side. This is based on equation, that's why. So this type of equation is very simple, because you don't need to be make it equal.